This question is on exam 3 review. It's number 14C. We're going to solve this radical equation. The first thing that I'd like to do is get one of the square roots by itself. I'm going to choose this square root because it is the one that has a more complicated inside. It's got a binomial instead of a monomial. So I'm going to subtract the square root of x from both sides so I can get that square root of 6 plus x by itself. Okay, so square root of 6 plus x is equal to 3 minus the square root of x. Now that I have that square root by itself, I'm going to want to square both sides. Okay, when I square this side, since it's two separate terms, I'm going to go ahead and just copy it over so that I can do my distributive property over here. I'm going to multiply this side all the way out. This side over here, when I square this side, the square root and the square root are inverses, so I just get the 6 plus x. Then on this side, I am going to get 3 times 3 is 9 minus 3 times the square root of x. Then again, another minus 3 times the square root of x, and a plus the square root of x squared. Let's simplify our like terms here. And that gives us x plus 6 equals 9 minus, those terms are like, they're going to combine to negative 6 square root of x, and then the square root of x squared is plus x.
So we've gone from two radicals in our equation to just one, and we're going to need to go ahead and isolate the radical that we have left, the 6 square root x term. So I'm going to start by subtracting the x and also subtracting the 9 from both sides. On this side I'm going to get negative 3. And on the right-hand side, I still have negative 6 times the square root of x. Now, I can square those right now, or I can divide out the negative 6 first. That's just a preference. I'm going to go ahead and square both sides, though, so I don't get fractions any earlier than I have to. Negative 3 squared is 9. And on this side, remember that the square applies to both the negative 6 and the radical. So I'll get positive 36, and square root are inverses again, and so I just get x. Finally, to solve for x, I'll divide out the 36. Reducing that fraction to lowest terms gives me 1/4 for a final answer. But remember, your answers are never truly final in an equation with radicals until you've checked them, since it's possible to do everything right and still get an extraneous solution. So I'm going to go ahead and check that answer by plugging it back into my original equation. I would have the square root of 6 plus 1/4 plus the square root of 1/4 equals 3. And as we did in class, I'm just going to go ahead and type that into my calculator and check to see that it's actually true. So in my calculator, I've got the square root of 6 plus 1/4, and then I'm adding the square root of 1/4, and I can see that I do get the answer 3, which is what I was expecting, and that verifies that the solution that I found is going to work.